The last part of our notes today will be atomic structure, so please put that title in your notes. We're going to discuss some stuff that I am sure that you have learned before, you have learned in middle school, or maybe even elementary school, but we need to hit the basics so we can have a discussion and apply it to more complicated ideas as we move through the year. So please draw a picture of an atom. I have an example up front. You do not have to make it exactly like this, but try to have a couple circles in the middle, put a positive sign in a few, and then leave some of the other ones blank. Around those, have maybe 2 circles like I have, and on those circles, draw a couple little circles with negatives on them. This will set us up for the framework of our atom. All right, it's going to be really important that you have a real sound understanding of the relationship of the subatomic particles that are in an atom. So obviously, we've already been talking about this a little bit with Rutherford and everything else, but the center of our atom is the nucleus, right? Well, the nucleus, the big part of that is the reason why Rutherford was able to discover it was that the alpha particles were deflecting, bouncing in, bouncing off of this solid mass. And that's the key. This is the mass of the atom and only the mass of the atom. We've talked about that, how the rest of the atom is empty space. That means that only in the center has mass. So it's the mass of the atom. The particles that make up the nucleus have all the mass. And it's a key word that we're going to learn in chemistry. It's called mass number. And the mass number is really indicating what the mass is of any given element. And the mass number is going to be the protons plus the neutrons. So I'm kind of giving away something that what's inside of the nucleus. It's going to be our protons and our neutrons. And those are the only things that have mass. These little guys on the outside, those are our electrons, right? Thomson discovered them, that they had a negative charge. Rutherford put them on the outside of the nucleus. Bohr put them in energy levels. And lastly, now we're basing it more off of that they are probably in this area or this distance away, according to quantum theory. This is not a perfect model. It's better, though, to label things with. So here's the big thing, though. Electrons do not have mass. Yes, they do, but we're going to assume they don't. They are 1,000 times lighter than a proton, so the amount of mass that an electron has is basically negligible to what we need it to be, so it is not important to us. Big thing, negative charge. Electrons have a negative charge. All right, let's move on to the nucleus. So first one, neutrons. Neutrons are in the nucleus. They have mass because they're in the nucleus, and a neutron is neutral. It has no charge. That's why you don't have a positive or negative sign in the circle where the neutron is. So a neutron is neutral, but it does provide mass. And the last one is a proton. And a proton has mass. And the masses of a proton and a neutron are basically the same. And it has a positive charge. All right, so if we transition to a worksheet that would look like this, and this is a worksheet you're going to get in a moment, we have a bunch of different relationships, as you can see. We have elements, symbol, atomic number, mass number, number of protons, number of neutrons, number of electrons, and charge. All right, well, we can talk about the relationships between these numbers. So let's take a look at number 1. I pulled up what it looks like on our periodic table. It says oxygen, right? And there's the symbol. And what are some of all these other numbers? Oh, let's kind of discuss it. Don't worry about this up here. Above on top of my sheet, this is the things that you need to kind of understand, is that my atomic number is always on the periodic table, and that's right here. Okay, that is 8. Okay, that is 8. It's an atomic number. The mass number already was given to you is 16. Well, where that comes from, right here, I round this up, 15.999, whoops, 9994 becomes 16. So that's my mass number. Besides that, there's not a lot of other things that this provides me. Okay, it does give me a symbol, right? That's O, so I can put that in there. But what are the rest of these relationships? Here are my subatomic particles, protons, neutrons, electrons. So I'm sure you've learned this before, but above atomic number, this would be very smart to know. And if you want to write it down, an atomic number is really the number of my protons. So if I put a P right there, I understand that that's my number of protons. So if I have an atomic number of 8, that means I also have the same number of protons. Here's the trick. Protons never change with an element. Protons never change with an element. If I change the number of protons from 8 to 7, if you look at the periodic table on your left, it goes from oxygen to nitrogen because they go from 8 to 7. It's the only thing. It's like the identity. It's the brain of an element. All right, so let's talk about what else we see. If protons are my atomic number, I have 8. My mass number says 16. My mass number says 16. Well, what did we learn in the previous page? Is that the mass is neutrons and protons. The mass number is protons and neutrons together. So if I have 8 protons and the mass number is 18, 16 minus that is my neutrons. So my mass number are my protons and my neutrons. So if I have 8, I must also have 8 neutrons. Final thing. How do I get to electrons? There's a charge here. So what things had charges? Well, we said that the protons were positive and the electrons were negative. So basically, you take your protons and you subtract your electrons and you get an overall charge. So I look at this and just take a moment and think about it. It says a -2. So which ones do I have more of? The negatives, which are electrons. How many more? 2. So do I have 6 or do I have 10 electrons? It should make sense that I have 10 electrons because I have 2 more negatives than I have positives. And that's kind of what we're filling in. So we'll do one more, number 2. And this is already an example done on your worksheet. But I look at this now. In this case, let me bring it up. Here is number 2 then. I brought this one up because I saw the symbol Ru. So I look at the periodic table and there it is. That's the only thing that actually helps me right now because I have neutrons and charge. Remember, protons or a symbol or atomic number are the only things that are going to help us. So first I can fill in the name, ruthenium. It's not one of the 46 you had to know, but it's ruthenium. What's the atomic number? 44. Immediately, what else do I know? Atomic number and protons are the same. In this case, I was not provided the mass number, but I look above and what I recall and I know is that the mass number are my protons and my neutrons. Now, this is a little different potentially. I get it. We're going to learn about this later in the week. It says 101.07. So some of you would round this and say 101. Problem is it's protons plus neutrons. We're going to have a discussion about a thing called isotopes later, but 44 plus 58 equals 102. So these two together equal my mass number. And here we are again with electrons. So this time I have a +2 charge. +2 charge, I have 44 protons. So how many electrons must that be? Well, again, you think about this quickly because it's opposite sometimes. I have +2. So you have to just slow down and say, okay, which one do I have more of? Positives. How many more? 2. So if it's 44 protons, that means I can only have, it's either 46 or 42. It would be 42. So this is the relationships that we're going to be learning in the beginning. Every single problem gives you just enough information. Okay? If you feel like it doesn't, think about what is already being given to you. If you don't have enough, then you need to use the periodic table. For example, if I wasn't giving you the neutrons, then you wouldn't have 58 here. You'd have to use this number for your mass number first. So then I'd say 101. And then because of that, I'd have 57 because 44 plus 57 equals 101. So take a shot at it. The answer keys up front, please check. Do not copy as always, and continue to work on that. If you have any additional questions, you can always write me an email and I will try to answer that in the evening. So good luck, and I will help you out if you need it.